Okay, so in this session we will discuss integrals of rational function of sine and cosine and sine. So the topic is residue integration of real integrals. So suppose the integrals of rational functions of cos theta and sin theta. First we consider integrals of the type J is equal to integral 0 to 2 pi f of cos theta sin theta d theta. For example, that means the integrals of this form. For example, if you take j equal to integral 0 to 2 pi f some rational function of cos theta and sin theta, that means sin square theta, for an example 5 minus 4 cos theta d theta. So if you want to integrate the integrals of this form, you can use residue integration. So for that, what we will do is, so for that we will set let z equal to e power I theta. Okay, z equal to e power I theta. Then what you know about what is e power I theta? Anybody?
Cos theta plus I sin theta.
I sin theta, and you know that e raised to minus I theta is equal to cos theta minus I sin theta. So we suppose that z equal to e power I theta. Then what will be cos theta? Cos theta is equal to e power I theta plus e power minus I theta divided by 2. So if you add this and if you divide by 2, you will get cos theta. And we know that we just substitute z equal to e power I theta. Then what is 1 by z? 1 by z equal to 1 by e power I theta, which is equal to e power minus I theta. So z equal to e power I theta and 1 by z equal to e power minus I theta. So thus we get cos theta is of the form 1 by 2 times z plus 1 by z. Okay. Similarly, what will be sin theta? Sin theta is equal to 1 by 2i times e power I theta minus e power minus I theta, which is equal to 1 by 2 times z minus 1 by z. Any doubt? Any doubt?
Yes, sir.
Okay. Is it clear? If you have any
Yes,
doubt,
sir.
you can ask. Now, we already put z equal to e power I theta. Then dz is equal to derivative of e power I theta with respect to theta. So we will get I e power I theta d theta. So dz is equal to I e power I theta d theta, which implies dz divided by I e power I theta is equal to d theta, which implies d theta is equal to dz divided by I into e power I theta is already we substitute as it. So d theta is equal to dz divided by I z. Okay, so our integration becomes in z dz format. Now we know that our integral, okay, so our integral ranges from theta ranges from 0 to 2 pi. So if theta ranges from 0 to 2 pi, that means z, then what z equal to e power I theta ranges from 0 less than or equal to theta less than or equal to 2 pi, means what is this is actually, if you go theta is equal to 0 to 2 pi, you will get a unit circle. So if theta ranges from 0 to 2 pi, that ranges from the unit circle. Okay. So our contour 0 to 2 pi changes to our contour unit circle mod z equal to. Any doubt? Any doubt? So, so I think it's clear, right? The theta ranges from 0 to 2 pi. Then the variable z e power I theta ranges counterclockwise around the unit circle mod z equal. Therefore, okay. So therefore, our integral j equal to 0 to 2 pi f of cos theta sin theta d theta, this equal to, this integral changes to j is equal to integral over c f of z dz divided by iz, where c is unit circle. So what is our contour? Contour c is unit circle. Now we will do a problem. So this is a real integral. Show that integral 0 to 2 pi d theta divided by cos theta is equal to 2 pi I 2 pi divided by root 3. Solution. So is it in rational function? Right. This is a rational function of cos theta. So we can use our the above method, right? So what we will do is put z equal to e power I theta, and theta ranges from 0 theta less than or equal to 2 pi. So I am substituting z equal to e power I theta. Then what is cos z? Sorry, cos theta. Cos theta we already, cos theta is equal to this 1 by 2 into z plus 1 by z. So we substitute that cos theta is equal to 1 by 2 into z plus 1 by z. Okay, that is cos theta. And so here there is only cos theta, and we know that d theta is equal to dz divided by iz. And what is our contour? Contour c is mod z is equal to 1. This is always mod z equal to 1. Now then our integral 0 to 2 pi d theta divided by 2 plus cos theta is equal to, this can be changed into integral over c. So our 0 to 2 pi changes to mod z is equal to c. Mod z is equal to 1. And d theta we substitute this, right? D theta we substitute it, that is dz divided by iz whole divided by 2 plus 2 plus cos theta. Cos theta, instead of cos theta you can write 1 by 2 into z plus 1 by z. So now our integral becomes a complex integration, right? So we will simplify this. If you simplify this, you will get integral over c. I is there, so constant 1 by I am taking outside, and dz divided by z into 2 plus 1 by 2 into, you can written as z plus 1 by z is z square plus 1 divided by. So this is 1 by I integral over c If you multiply this, you will get dz divided by 2z plus z square plus 1 divided by 2. So this is equal to 1 by I integral over c dz divided by 4z plus z square plus 1 all divided by 2. So now this I can change it into 2 can be taken outside. That means 2 can be taken outside. That is 2 by I integral over c dz divided by z square plus 4z plus 1. So this is equal to, so our integral, like, so our integral changes into integral 0 to 2 pi is equal to 2 by I integral over c f of z dz, where we know that c is mod z equal to 1. So this is simply a complex integration. Now we will find this, okay, this integral. Then, so for that, if you want to find that integral, our f of z is of the form f of z is 1 by z square plus 4z plus 1. Now tell me what is the singularity here? Anybody? Roots of this polynomial. Here f of z is equal to 1 by z square plus 4z plus 1 is analytic everywhere except at, what are the roots? Anybody? Z equal to, this is a quadratic equation. So when the denominator becomes 0, tell me.
Plus or minus root 3 minus 2.
Plus or minus like minus 2 plus or minus root 3 അല്ലേ?
അതെ
Is minus 2 plus or minus root 3?
Yes, sir.
Okay. So now we have to check whether these two singularities inside C. What is C? C is the unit circle, right? So our C is unit circle. Mod z equal to 1. So how to check? So now z equal to minus 2 plus root 3. Then what is mod z? Mod minus 2 plus root 3. Is it less than 1? Minus 2 plus root 3. Modulus of minus 2. Yes. So that means this point, this is inside C, right? Because this is less than, modulus of this quantity is less than 1. Now what about, now if for z equal to minus 2 minus root 3, it implies mod z is equal to modulus of minus 2 minus root 3. Is it less than 1 or greater than 1?
Greater than.
Is greater than 1. Therefore z equal to minus 2 minus root 3 is outside the circle C. Thus f of z is equal to 1 by z square plus 4z plus 1 is analytic everywhere everywhere except at z equal to minus 2 plus root 3 inside C. So we will consider the singular points inside C only, right? So there is only one singular point inside C. Now we want to find the residue. So we know that the integral over C f of z dz is equal to, by residue theorem, this is equal to 2 pi I residue of sum of residue of f of z, right? So we want to find, there is only one singular point, so we want to find out residue of z equal to minus 2 plus root 3 1 by z square plus 4z plus, now we can use some formula. Actually, okay, I will write it. 1 by z square plus 4z plus 1 is of the form p of z divided by q of z, right? What is p of minus 2 plus root 3? Is it what is p of z? P of z is 1, right? So from here, p of z is 1 and q of z is z square plus 4z plus 1, and q dash of z is 2z plus 4, right? So p of z is always 1. So p of minus 2 plus root 3 is 1, that is not equal to 0. Now we have to check what is q of minus 2 plus root 3. So q of minus 2 plus root 3 is 0 because this is the root of this polynomial, right? Now we want to check whether q dash minus 2 plus root 3 is equal to 2 into minus 2 plus root 3 plus 4. So this is equal to minus 4 plus 2 root 3 not equal to 0. Then tell me what is residue. So this is not equal to 0, therefore we can use the formula. It is P of minus 2 plus root 3 divided by q dash of minus 2 plus root 3. Tell me what is the answer, residue. Residue എന്താണ്? What is residue? P of minus 2 plus root 3 is 1. And what is q dash of minus 2 plus root 3? 2 root
2 root
3.
3.
Okay. So residue is 1 by 2 root 3. Okay. Is there any other singularity inside C? Is there any other singularity inside C? No, right? Because there is only one singularity inside C. So now we will find the integral. What is integral? Integral over C f of z dz is equal to 2 pi I into sum of residues of f of z. So this is equal to 2 pi I into, what is the residue? There is only one residue is there, that is equal to this. So 1 by 2 root 3. So I am cancelling out these two. I will get pi I by root 3. So integral over C f of z dz is pi I by root 3. But what we have to calculate? We have to calculate this. Right? So, this, right? Which implies integral over 0 to 2 pi d theta divided by 2 plus cos theta is equal to this, right? 2 by I integral over c, 2 by I integral over c f of z dz. So therefore this our final answer. We have to calculate this integral over 0 to 2 pi d theta divided by 2 plus cos theta is equal to, we already know that this is 2 by I integral over c f of z dz. So this is 2 by I integral over c of z dz is pi I divided by root 3. Now I and I get cancelled. So this is 2 pi by root. So this is very easy comparing to other problems. Okay. So is it